Thank you for coming to our talk. I'm Ramiro from Pivotal.
I'm Laurent from Google.
So we're going to be talking about connecting all abstractions with Istio. So we have only 30 minutes for this talk. It should be double the length at least, so we're going to go fast. First, I think it's no surprise for anybody that this is about microservices. Microservices really was driving the need for this kind of technology, and that's the main reason why it exists and why we're here talking about this. Microservices as software entities that communicate with each other, they have expectations from the network world, right? They expect to be, obviously, the network needs to be available, needs to be there, needs to be fast, needs to be secure, needs to have a low latency, needs to be transparent, and never fail, which, of course, is very unrealistic because we all know better, right? That just doesn't happen in real life. But that's essentially what, in the ideal world, you should see out of the network. That's the expectation. Network, at the same time, has other expectations from microservices. And when I talk about the network here, I'm talking about IP networks in the standard sense of the word, like large-scale IP networks, service provider networks, et cetera. The service provider networks, the IP network world, does not provide you with some basic constructs that are very important in the microservices world. Some of those constructs are service discovery. So the expectation from the network is, if you're going to implement microservices, you bring your own service discovery. There's a number of good technologies out there, like Eureka, like Consul, et cetera. A number of technologies out there that provide you with service discovery. None of them are native network technologies. They're all essentially augmentations. They're applications technically running on top of the stack, of the ISO stack. So from that perspective, the network expects that you have service discovery. The network expects that you have your own app-level flow control. Network provides you with flow control in TCP. TCP does that natively. But it's one type of flow control. It's not a more sophisticated, application-aware type of flow control. Implement your own internal security. That should be obvious to everybody. Everybody should know that an application developer should always be concerned about application security. There is expectation that the network is going to provide you some degree of security, which is essentially visibility and access, which are the basic aspect that you expect that a network provide to you. But anything beyond access and visibility should be driven typically by the application layer. Now, obviously, there's an expectation that you're going to implement your own service protection in case of a network partitioning. This is particularly hard, right? Network partitionings do occur, right? And some systems that run on top of IP networks have to implement their own protocols and their own systems in order to balance out the risk and the potential that there's going to be a network partition. Some systems, for example, like etcd, like we've had some issues in the past with that, right? If you have 3 nodes, there's a network partition. After a certain amount of seconds, you're going to have 2 clusters, literally. One cluster of 1, one cluster of 2. And even if the network gets reconnected, you're going to have problems merging those 2. There's going to have different views of reality. So it's a complex problem, right? When you start dealing with the microservices world, the networks as they exist today are not necessarily as flexible or as complete as you would like them. Microservices have much more complex needs than what the IP networks can typically provide today. Like health service checks. That's something that you don't expect that the network is going to give you, right? Or extensive metrics. Yeah, the IP networks provide metrics typically through the routers, through the switches. You have, open flow, some protocols that can actually send span traffic out. You have things like NetFlow and IPFix, and a number of other protocols that can actually help you see packet metrics. But they don't give you application-level metrics or microservices-level metrics. Those are different type of metrics. You have patterns that have emerged in the last couple of years, like circuit breakers, that are extremely popular with microservices implementations. And the networks do nothing to help you with that, because it's not essentially their job. You have high-level flow controls and QoS, or advanced policy controls. When we say policy, we're talking about much more complex policy than just a typical firewall input and output type thing. We're talking about more complex policy that involves, for example, geolocation. That's a policy. It's not a network problem, but it's a services problem. So IP networks can't really provide you all that by themselves. Now, since we start merging these 2 worlds, microservices and networks, there's new protocols that have started to emerge, right? Some of these things, like HTTP2, start looking into much more complex flows of communication. gRPC, fantastic protocol that try to bring levels, one level above the communication between the system, leveraging HTTP. For the IoT world, you have protocols like MQTT or CoAP, right, that specifically deal with the complex needs of IoT environments that are trying to send constant data to microservices consuming that data. But at the same time, you still have other needs. Like the older needs don't go away. You still have things like encryption everywhere is a requirement. You have HTTP 1.1 that you're going to probably deal with it for the foreseeable future. Raw TCP, raw UDP, multi-UDP ports, there's all sort of requirements. So all these new beautiful protocols that are coming out are not necessarily enough. They're an evolutionary path, but they're not necessarily the panacea for all this. So 30 years ago, when I started doing networks, we used to build protocols ourselves. We would have done that. I mean, we had Banyan Vines, we had IPX, and other protocols that we built, essentially, ground up for specific purposes. Now, in today's day and age, it's not realistic, unfortunately. The battle is won. I mean, the network, when we say network, is IP. IP is everywhere. There's no room for other protocols right now. There's definitely an evolution of IP towards IPv6. It's a different story, but it's essentially still the same concept as IP, right? So what do we do in order to address this? We augment the network. And this is a brilliant, brilliant idea that came up a couple of years ago as a pattern. So instead of having a direct communication with each one of the software entities talk to each other directly, which is what you would do if you have to code a service today, open a TCP socket, connect against the other service, establish your own flow control, trust that TCP will do that flow control for you, implement your own security, implement your own service discovery. Basically, that's what you would have to do today. Instead of doing that, we just moved to a sidecar model. So instead of doing direct communications, we lie to the applications, we lie to the microservice, and we make them believe that they are talking to the other endpoint, when in reality they are talking through a proxy, right? It's a very, very small proxy, very efficient proxy, but it actually does a lot of more logic than just the application can provide directly. It helps the developers so you don't have to start coding a lot of things yourself. You let the network now deal with more complex patterns like circuit breakers and so on. This is a brilliant idea. I like to compare it with partitioning a hard drive. Anybody here partition a hard drive ever? Everybody, of course. So in the old days, there used to be like 4 partitions. That's all you could do, right? So obviously, that's never enough, right? So some genius at some point figured out that the 4th partition can be used as a pointer to other partitions instead of doing regular partitions. This is sort of like what's going on here. Essentially, you cannot go beyond layer 7 in the IP stack, but they figure out a way to expand beyond that and adding new services through an alternative mechanism. That's why this is so creative and so potentially revolutionary as a pattern. You have to add, obviously, a control plane, because all these proxies talking to each other, they need to be, obviously, behind certain business logic behind it. So that's what we call essentially a service mesh as a concept, right? Basically, all these microservices are connected with each other. They're connected using this proxy mechanism, and they have a control plane mechanism, right? There's a market for this, right? It's a pattern that started emerging a couple of years ago. You have software like Linkerd, Envoy, that HAProxy itself is evolving into this, Trafic, and there's some other ones that provide you this data plane aspect of this, right? And then you have other control planes such as Istio, Synapse, Nelson, and there's other ones, even commercial ones out there that are evolving on their own nature, right? So this is a market that is starting to appear from the bottom up in the last couple of years. It's not a pattern that you see everywhere, or it's not a pattern that has a lot of awareness in the CF community in particular, but it's starting to appear in a lot of places. So let's discuss about Istio specifically.
Hey, hi. Istio is a project that we started about a year ago. It's a collaboration between Google, IBM, and Lyft, and more people from the open source community are contributing. And one of the things I would love to get out of here is also more contributors and maybe more users as well. So the key idea, as Ramiro said, behind Istio is try to let people focus on their business logic in their service and not have to re-implement over and over security, metrics, monitoring. Those are key to make real systems in production, but you don't want to have to keep reinventing those over and over and get them wrong. Especially security, I think, is very important to get right. So the way we achieved that with Istio is we picked a sidecar, as he explained, and that sidecar is Envoy by Lyft. And it has a bunch of features that are here, and I'll go over the details. So Envoy is the sidecar. It's in C++. It's a very small footprint. And it's production battle tested by Lyft. It's doing millions of requests per second, and it's very stable. There's a bunch of features. Istio, we also, during the development, improved some of the features related to routing and higher level components. So the sidecar is one element, but then which gives you basically point-to-point authentication and lets you have a, I guess, smarter load balancing than what you get by default. For instance, if you use Kubernetes, the default implementation is just going to be a round robin. With Envoy programmed by Istio pilot, you can have much richer sets of rules and much better view and management of your services. It also captures all the telemetry and automatically injects the Zipkin trace IDs, so you don't have to deal with all that, and you can see spans and the view and manage your services without writing any new code, basically. So the components in Istio are, so Envoy, the sidecar, which lives with your service, and all those envoys, all those sidecars are configured using Pilot. So what Pilot does is it's the translation between all the service discovery, service registry, your list of endpoints, and your rules in order to program Envoy. Mixer is the policy engine. It's how you can write rich rules and expand your system to both capture the telemetry and enforce your policies. And Istio Auth is the component that lets you manage the certificate and the secure naming and secure services. So a bit more about Mixer. That's one of the key ideas in Istio is we want it to be extensible. But we also want to preserve the integrity of your service. So everything, we try to run only the minimum in the same container or the same host as your service. Everything else is being pushed into Mixer. We use caching in order to make it performant. And that's a point where you can extend and plug in any backend that you need to do your own version of quotas or your own tracing or your own logging and so on. And Pilot, as I mentioned, is the way you adapt from your actual platform to the specifics of configuring each sidecar. It also gets in the configuration, the rules from the user, and then programs all the Envoy. So one thing that's nice with Envoy that I could have mentioned earlier is that it's a kind of newer code base, and it's programmed through APIs, so you don't have to restart Envoy to change the configuration, for instance. And Istio, the last big component inside Istio is what lets us automatically provision certificates for each service and ensure the security of the system. So one of the things that I personally work on is environments, which is the idea that while we started with Kubernetes, we do want Istio to apply more broadly than that and not be tied to a specific platform. So today in 0.2, which is only our second release, so it's still alpha from the fall, we support multiple namespaces in a single Kubernetes cluster, and there's some initial implementations of console and Eureka adapters. But we also provided a way to expand your Kubernetes cluster with VMs that are not part of Kubernetes. And I'll talk a tiny bit about that. We don't have much time. And just a heads up on what's coming very soon on Istio in terms of support. We are going to support more than one cluster and also be able to join a hybrid set of clusters on different cloud providers when the network is not a VPN. And obviously, there's a lot of CF work that's going on that Ramiro will talk about. But just a tiny bit about the mesh expansion. The mesh expansion is interesting because it lets you understand the components that you need when you're outside of an orchestrated environment. How does Istio actually work? And the way it works is you have a provisioning step where you have to bootstrap the certificate for the security. So you have to use your service account, your admin service account, to bootstrap certificates and install them on the machine. After you've done that, you can install packages like the Istio node agent that's going to maintain that certificate, renew it periodically such as it stays valid. And when you're inside a orchestrated or a container, what the Sidecar does is it intercepts all communications in and out of your application. Obviously, if you have that on a VM, you don't want to do this because you would not be able to SSH into the box. It will try to get an MTLS into Envoy, and that's not going to work very well. So there's a difference in the mesh expansion use case where instead of automatically intercepting all the traffic and securing it for you, you have to actually explicitly list which of the ports you're interested in capturing and managing. An interesting point also is like the DNS. When you name your services inside a Kubernetes environment, you don't get, those names are staying inside kubedns. They are kind of private to the cluster. So what we're doing in the Istio mesh expansion is we let you use DNS mask and kind of merge the two DNS, your on-prem DNS and your in-cluster DNS. And on this, I will give it back to Ramiro.
One of the things that we really like about Istio in general is that it's cloud agnostic. It's not a product that is Kubernetes-centric. There's obviously, it adapts very well to Kubernetes, but it's essentially cloud agnostic, so it can be applied across multiple systems and multiple abstractions. One of the attractive aspects for us is the implementation of Istio across different components of what we have in the Pivotal stack. As you've seen during this conference, the Pivotal stack is evolving. It's no longer just the traditional Elastic Runtime, or PAS as it's now called. But there's also now the PKS component of that, or our offering to create Kubernetes clusters, right? That we're jointly working with Google and VMware, right? So there's a number of particular new abstractions. Now you have function as a service as well. So there's other elements that we need to connect. And since Istio is a technology, or the service mesh as a concept, it can cross boundaries. It doesn't really care so much about what's really underneath. It's a perfect abstraction for us to connect all these endpoints. So there is already work going on at the moment in the Elastic, in the container runtime piece, which is Kubo in particular. This is actually the easiest part of all, right? Kubo is a product that is essentially designed, or CFCR now, is a product designed to delight a person that creates Kubernetes clusters, right? It's not a Kubernetes distribution. It's a tool to create Kubernetes clusters that can be used by anybody that needs a Kubernetes cluster. So it is very possible now to generate a vanilla Kubernetes cluster that is very up-to-date, and is all controlled and managed by Bosch, and it has a strong isolation because Bosch enforces that strong isolation. And Istio, like Kubernetes, typically is not very strong in multi-tenancy. There is a lot of work being done right now at the moment in the Kubernetes community to enhance multi-tenancy, but there's nothing like Bosch in the sense of the goodness that it provides by providing this hard isolation by separating VMs or different zones in general. In order to set it up, it's actually quite simple. If you have ever worked with the CFCR or Kubernetes implementation, or the Kubo implementation, I keep calling it Kubo. I know it changed names, so you got to forgive me about that one. You typically deploy your Kubernetes cluster. You call your Kubo implementation with the scripts, and you deploy your Kubernetes cluster with this, right? You call it my cluster in this case, right? Now, the next thing you do, you target your environment. So at that point, from that point on, every kubectl command that you do, you're going to actually be working with that cluster, right? So the next thing you do, you obtain your Istio release, and security guys will have to ignore this monstrosity that I put in there, but it's the way right now. This is, I mean, we're talking about 0.8, 0.2, 0.3 came out the other day. So this is the versions that we're dealing with, right? So it's pretty early on, consider it experimental, but this is one of the things that you do to install the software at the moment, right? After you do that, you have a choice. You can either automatically tell the cluster to inject sidecars, inject these Envoy proxies in every single microservice that you deploy, or you choose not to, right? Depending on what you actually want to do, right? If you want to do it manually. So the process in order to install it automatically is called Istio initializer. Initializer actually abstracts all that, right? It essentially allows you to deploy any microservice that you do it, and automatically it will inherit all the benefits from Istio technology. So once you have it all running, you verify that it's actually running, and here you have it. You have your environment there, and you have these are the services that you should see that belong to the management aspect of Istio right there. You have two options now to deploy your app. You can either deploy it, if you have the initializer, you can use the upper portion of that. You just do a typical kubectl create, and you point to your YAML file for the application itself, or your microservice. Or if you didn't install the initializer, you can forcefully use the Istio CTL in order to inject the sidecar right there. You can have mixed environments as well, with sidecars, with no sidecars, et cetera. We foresee that in most environments, you're going to have them with sidecar automatically, and it's going to become a natural element of the network in most cases. In the case of application runtime, what people know as the elastic runtime typically in Cloud Foundry, we have several phases of implementation that we're actually working on. The first phase is injecting Envoy into every application instance in order to enable mutual TLS. This is part of the route integrity work. There is a very, very good talk from our colleagues, Angela and Gabe, that they did in Cloud Foundry Summit, and I believe there is another version of that talk in this conference. You should definitely look it up, because that explains in depth the work that was done in order to enable the route integrity work, and why we did this particularly, some of the limitations of the NATS protocol in order to receive routes, so the Go router can actually receive routes. The phase 2 that we're starting to look at right now is the ingress. So this has the potential of replacing the routing tier right now for Cloud Foundry, essentially replace the Go routers, replace HA proxy, replace NATs, right? And provide Istio, particularly as the glue to connect all these elements, and use Envoy for ingress, right? So Envoy is so small and so efficient that it can be used for all these purposes. It can also be used as an ingress system. So using Pilot to provide now route updates, and in order and we finally get rid of NATs, which has caused all sort of headaches over the years. Yeah. I know there's some fans over getting rid of NATs. And the phase 3, once this is implemented, is east-west traffic. Because once you have this in the north-south aspect of this, it becomes very easy and very natural to expand this sideways, to essentially do app-to-app and app-to-service integration via Envoy with mutual TLS. Services don't have to be necessarily internal in Cloud Foundry only. It can be fronted externally. There's technically nothing that can stop you from putting a Raspberry Pi in front of a mainframe. I know that's crazy. But literally make it part of the mesh that way. That's essentially possible, right? And you can also do east-west traffic and replacing potentially what we have today as CF networking. Right? Now, that being said, the constructs and the simplicity of use that made Cloud Foundry popular, that doesn't go away. All these ones are internal things that are occurring within Cloud Foundry. This embracing of these technologies are internal optimizations. The simplicity of the CF push, the simplicity of the CF allow app 1 to talk to app B over port whatever, that doesn't go away. Those things are still essentially the same and are part of what made Cloud Foundry a popular platform with developers. And finally, in the part of the phase 3 as well, we're looking at integration with a policy engine. We're exploring Mixer right now. It's not currently in scope for what we're looking at. There's no experiments going on Mixer, but we're starting to align our interest around how we want policy to look like. Policy is a big topic. It's not just network policy. Policy is policy. It deserves its own talk. It goes separate and is orthogonal to many of these components, and it touches also IIS components and other systems that are outside the purview of Cloud Foundry. So it needs to be dealt in a separate way. So we're going to be looking into that as well coming in the future. One of the reasons why we wanted to present this, and this is what we're thinking about doing, right? Some of this part is obviously being implemented already. Some other ones are progressively being added. Some other ones are thought experiments at the moment. But one of the things we need from you, our customers, our friends, our partners, is to make sure you give us input. Is this the right approach? Is this something that you would like us to keep working on? Is this something that would solve problems that you already have? Are these things going to introduce other problems that you think they would be introduced by this? We want to know all those ideas, all those thoughts early on in the game so we can factor that in as part of our decision-making process. We want to do all this openly in the community. So our goal is to abstract all abstractions across using Istio as a glue. So you can imagine a future, for example, where you can have apps that you can do your CF push, for example, apps or microservices to a CF space or functions into PFS, but at the same time seamlessly discover and consume other apps and functions in the same platform or across platforms. Now that you have a service mesh, there's no boundaries, there's no hard boundaries. You could potentially expand this mesh between orgs and different PCF foundations, or between orgs against Cloud Foundry-generated against PKS-generated Kubernetes clusters. So a developer can create a cluster for their own consumption and use that, even temporarily, even if it's a part of the deployment, and then just literally wipe it away, right? All the same constructs that you can do. It doesn't have to be bound by the specific nature of a single vertical cloud. It can go beyond different clouds. It can go to some elements can be deployed in AWS, some other ones in Google Cloud, some other ones in other clouds that people may have, internal or external. You can have pods in Kubernetes consuming apps and microservices in Cloud Foundry, but connected to the same service mesh. They can be even internal to that mesh or that portion of the mesh. You can add now mutual TLS to everything with advanced telemetry, QoS, circuit breakers, end-to-end policy controls. It's extremely sophisticated, so the potential for this is very big, right? But again, I want to be very clear that this, you got to take it with a grain of salt. It's difficult to see where this thing is going to go in the future, right? And we want to be cautious in terms of how we approach this. Some of this is very early on, but because it's early on, it has a great potential to be shaped in a way that is going to solve real user problems. And that's ultimately what we all want to do. Otherwise, why we're doing products, right? That's it. Right. Thanks.